Hello students, in this video we are discussing basic operations on signal from our unit number 1 fundamentals of signals and system. On this topic TLO number 5, that is topic level outcome, is performed dependent signal operations. TLO 6, perform independent signal operations with the level L2. So students, already we discussed the definition of signal. So signal is based on the physical phenomena which is depending on one or two independent parameter. So for example, temperature is one of the physical quantity which varies with respect to time. So in temperature, time is the independent parameter. In the similar way, normally 1D signal, voltage or current, we represent with respect to voltage change with respect to time. So voltage we represent normally on y-axis, which is represent as a strength of the signal or amplitude of the signal, and x-axis represent the time axis. So based on this dependent axis and independent axis, we are having two types of operations, that is dependent operations and independent operations. So when we work on a y-axis on strength of the signal, on amplitude of the signal, that operations comes under the category of dependent operations, and when we work on a independent axis on time axis, that operations comes under the category of independent operations. For example, here this is the discrete signal, where in discrete signal x-axis represents number of samples, y-axis represents the amplitude of samples. So based on this, first of all we will see what do you mean by dependent operations. For the simplicity, we are considering here discrete signals. So in front of you, the two discrete signals are given, x1 n and x2 n. There are the different types of dependent operations: amplitude scaling, addition, subtraction, multiplication. So by performing these dependent operations on our signal, what happens? There is a change in amplitudes, there is a change in strength of the signal. So that's why this operation comes under the category of dependent operations. Now for example, here we are performing amplitude scaling operation on signal x1. So original x1 signal lie in between -1 to 2 with the amplitudes 1 and 2. So now in amplitude scaling, what is the equation, mathematical equation for amplitude scaling? Y of n is equal to 2 into x1n. So now here we have to plot y of n by performing amplitude scaling on x1. So for that purpose we have to multiply x1 signal with the 2. So 2 is the scaling factor. So for example, here on -1, original amplitude is equal to 1 multiplied by 2. So for y of n on -1, we are getting amplitude 2. So see, I am drawing here on y of n on -1, we are getting amplitude is equal to 2. In same way, on 0 for x1, original amplitude is 1 multiplied by 2. So on 0, again here amplitude is equal to 2. Next on 1, original amplitude is 1, 1 multiplied by 2, again here 2. On 2, original amplitude is 2, so 2 multiplied by 2 is 4. So after performing amplitude scaling operation, what we are doing here, we are using scaling by 2. Here there is a change in amplitude of the samples. For example, next operation here, addition between the two discrete signals. So these are the two, x1 plus x2 we have to perform, which comes under again. So now while doing this addition, we have to take care about the independent axis. So for example, here on x2 on -3 amplitude is 2, on x1 on -3 no sample presents, means 2 plus 0. So here on -3 for y of n, amplitude is equal to 2. On x2 on -2 amplitude is 3, on x1 on -2 amplitude is 0, no sample presents, means 0 plus 3. So on -2 amplitude is equal to 3. Next on x1 on -1 amplitude is equal to 1, on x2 on -1 amplitude is equal to -1. So 1 plus minus 1 becomes 0. So that's why on minus 1 there is a no sample, the value of the sample is equal to 0. On x1, on 0 amplitude is equal to 1, on x2 amplitude is equal to 1. So 1 plus 1 becomes here 2. So on 0 for yn amplitude is equal to 2. On 1 amplitude is 1 for x1, for x2 on 1 amplitude is 1. So 1 plus 1 becomes 2. Next, on 2 amplitude for x1 is 2, on x2 amplitude is 2. So 2 plus 2, 4. Likewise, again on 3, here 2 plus 0, 4, 3 plus 0, 3. So here, hence we completed here which operation? Addition operation, which is the dependent operations. So again I'll repeat, in dependent operations we are performing operations on amplitude, on strength of the signal. Next, now here the second type of operation is independent operations. These operations now we are performing on independence axis. So this is our independent axis. Again in independent operations there are the three types of independent operations: time shifting, time folding, time scaling. So first of all we will complete the time shifting. In time shifting again there are the two types of operation: time delay and time advance. So time delay operation represents by x of n minus k. So x of n, so this round bracket represents, it's a function of n. N is number of samples. So n minus k. Minus sign indicates time delay operation. K is amount of delay. So for example, this is the original signal, x of n is given. So original signal x of n starts from minus 3, ends up to 4. So means now we have to perform this time delay operation on independent axis. Delay means we have to shift this signal on right side. Meaning is what? For example, consider your class starts by 10 o'clock. So in place of 10 o'clock, your class starts by 10:15. So how much is the delay? 15 minutes is the delay. In the same way, in place of this minus 3, your sample starts from minus 3, your sample starts by some delay amount. So that delay amount is represented by the value of k. Now for example, see here, this time delay shifting by x of n minus 1. So minus sign again indicates delayed operation, 1 indicates the amount of delay. Okay. So to perform this time delay operation, what we need to do? Shift this signal on right side. Okay, shift this signal on right side by k. How much is here k? By 1. Means in place of this signal starting on minus 3, because of delay, now this signal starts on minus 2. So this signal, this x of n, we have to shift on right side. So I am first of all drawing here x of n minus 1. So in place on minus 3 amplitude is 2. So now because of delay, this signal starts on minus 2. So on 2 amplitude is 2. On now this 3 shifts on minus 2, minus 2 shifts on minus 1. So on minus 2 amplitude is 3. Minus 1 shifts on 0. On minus 1 amplitude is minus 1. So which shifted on 0. On 0 amplitude is 2, which shifted on 2. On 2 amplitude is 2. On 1 amplitude is 1, which shifted on 2. On 2 amplitude is 2, which shift on 3. On 4 amplitude is 3, which on 3 amplitude is 2, which shift on 4. On 4 amplitude is 3, which shift on 5. Okay. So because of delay, see here, this is the amount of delay which comes because of the time delay operation. So in place of minus 3, signal starts on minus 2. So this is our delay. Okay, this is the delay, and that delay amount is, this is the delay, that delay amount is your -1. Okay, so with the help of this, for the time shifting delay, we have to shift the signal on right side. Next type of time shifting is the time advance. So in time advance, it's represented by plus sign, x of n plus 1. So again, for example, in place of class starts by 10, in place of 10, the class starts on 9:45. Okay, so that is the advance. So in the same way, in place, in this signal, if we want to perform time advance operation on x of n, what we have to do, this sample in place of common -3, it will come before this value. So this sample comes on -4. So for that purpose, for time advance, time shifting in advance, that is x of n plus 1, we have to shift this signal on left hand side. Okay, so now we are shifting this signal on left side by how much number of samples? By 1, because it is given x of n plus 1. So because of that, this -3 sample on -3, the amplitude is equal to 2, which comes on 4 with the amplitude 2. -2 amplitude is 3, which comes on -3. -1 amplitude is -1, which comes on -2. 0 amplitude is 2, which comes on -1. 1 amplitude is 1, which comes on 0. 2 amplitude is 2, which comes on 1. 3 on 2 amplitude, on 3 amplitude is 2, which comes on 2. On 4 amplitude is 3, which comes on 3. See us. So because of the time advance, in place of this signal starts on -3, now this signal starts on -4. So that's why this is called as advance operation, and for the advance operations we have to shift our signal on left side of the signal. For delay, we have to shift the signal on right side. So this is very important. For delay signal, shift the signal on right side. For advance signal, shift the signal on left side. Okay, so thank you.